The Pythagoras theorem is a squared plus b squared equals c squared. What that means is we're talking about the square areas. So we're not talking about edge length. A plus b is not equal to c. Okay, that's impossible. But what we know is that this square here and this square here is equal to the bigger square off the edge. Okay, so we're talking about square areas. And this only works for right-angled triangles. Okay, so if it's not 90 degrees in that corner, this does not work. So only for right triangles. So relationship is the two smaller squares add up to the big square. So we're going to use this relationship and we can find the square areas. So if I have an edge length here of 10, well, that edge length is going to give me a square area. That square area is going to be 100 squares. If I have an edge length of 4, this square area is going to give me an area of 16 squares. And what we then do is use those squares to find out the third square. So that diagonal square is the biggest square. So then we can add those two squares together to get 116 squares. That would be awkward to draw, but we know that area here, which I'm going to highlight, this area we know is 116 squares measurement. Okay, we can fit 116 squares in there. And again, we're going to end up using that to find the edge length x. So we know that x squared in this diagram, we can just say that the x squared is equal to 116 squares. So here we have the edge length of 3 and 6. So edge length of, we'll start with the big edge length. So we'll say the edge length 6. This edge here is going to give us the square area of 36. So that's going to be our square area, this diagonal square. That's the biggest square now. Okay, so that's a square area of 36. We do know one other edge length. This edge length is 3. So we know that this square area here, that square, is going to give us 9 squares. So 3 squared is 9. Now, using those two squares, we want one of the smaller squares, so we're going to have to subtract. We're going to have a big square of 36, and we're going to take away 9 squares, and we're going to get 27 squares. Okay, so that 27 squares then, if I were asked to, I'm going to use that 27 squares, and I can square root to find the edge length. But right now, the relationship is really just about area, and so we want side length. So calculating the side length now for edge length x, we're going to square root 116. So the edge length, I'm going to write this in. So x is equal to square root 116, which is about, in decimal form, square root 116 gives us 10.77. For y, we know the area is 27, so we square root it to get the edge length. Square root 27 gives us an edge length of 5.19, so I'm just going to round that to 5.20. Okay, so that means that this edge length is 5.2. This edge length here, that edge length is 10.77. And then lastly, we're going to work out the edge length of, it says z, but y, but we're actually finding out z here. We know that a squared plus b squared, so we know that the square is 25 here. The square from this shorter side is 25. So we know that z squared must equal 25 plus 25, which is 50. So the edge length Z is square root 50, and that's approximately, when we work that out, square root 50 is about 707. Okay, so 7.07. If you want to round that to 7.1, that's perfectly fine. But that's our edge length, the square root 50, which is 7.07.